What's up, math fans? Hopefully, when you dealt with triangles, you heard the word tangent before, kind of back when you did SOHCAHTOA. Well, now we're going to do properties of tangent lines. And a tangent line is an actual line, like this blue line here, that touches a circle at only one point. So right here, you see point T, that's my point of tangency. Circle O and line, the line touches that circle O at just point T, the point of tangency. What's nice about it is the rule is a tangent line is perpendicular to the radius. So if I said blue line, I apologize. The tangent line is actually black. The blue line is the radius. So I'm going to use my markers that one of my students got me. Thank you very much. To show you that this is a right angle. The tangent line is perpendicular to the radius, therefore it forms a right angle. And now we're going to start to explore everything we know about right angles, because that tangent line, which forms a right angle with the radius, is going to lead to a lot of cool stuff. Like, oh, I don't know, here's a tangent line, here's a radius, right angle, right triangle. Here's a tangent line down here, CB is the tangent line, here's a radius OB, guess what? Right angle right there, right triangle again. We're going to talk about that. Here, I did not draw the radius because I'm going to teach you something new up here. All right? Speaking of circles, they make me think of ice cream. I like ice cream. They come in circle shapes, like chocolate ice cream, and vanilla ice cream, and banana walnut ice cream, and, oh, sorry, I went off on a tangent. Did you see what I did there? Tangent. See, because if we're having a conversation, and let's say the conversation is following some kind of pattern. We're talking about this, we're talking about this, we're talking about this. We're going into some kind of a pattern. And all of a sudden, you decide to go off on a tangent. It means you're going off topic instead of completing the pattern of the conversation, which would have completed a circle. You went off on a tangent. You get it? All right? So maybe that'll help you remember what a tangent line is. Okay, back to the properties of tangent lines. So we discovered that they form right angles with the radius, and they only touch the circle at one point, and also tangent lines coming from the same point off the circle are congruent to each other. It's another property. So here, PA is congruent to PB. This is congruent to this. All right? So if you're ever asked to find, let's say, solve for x in a problem like this, well, that's real simple. I know that PA is congruent to PB. Therefore, 2x plus 1 is equal to 15. And then you use your algebra skills. 2x equals 14, divide by 2, divide by 2, that's a 14 there. 2's cancel, and x equals 7. X equals 7. Okay, so that's your next property, is that tangent lines from the same point to a circle are congruent. Well, let's look over here. If you learned anything in this picture, you'll be able to figure out this picture very quickly. It's a popular question on a test. To give you this inscribed circle, you got your circumscribed triangle, and they'll say find the perimeter of the triangle. Perimeter. In order to find perimeter, you got to add up all the sides. Well, let's see. You just told me that tangent lines are congruent to each other from the same point. So just because AB is 14, don't think that CB is also 14. That's not true. I should be more specific now. When I said tangent lines are congruent, I should have said tangent line segments are congruent. From P to A is a segment, from P to B is a segment. A to B, I wouldn't consider a tangent segment. A to E is a tangent segment. B to E is another tangent segment. So that's two different tangent segments. So we got to be very careful. A to E is congruent to A to D. From A to E, A to D, those two are congruent. Now look at C. C to D is the same as C to F. And finally, E to B is the same as F to B. All right? Now we got to start doing some clever mathematics. Let's see. If this whole thing is 14, oh, well, this is 4. This has got to be 4. The whole thing is 14. 14 minus 4 is 10. That leaves me a 10 here, which leaves me a 10 here. Now, this whole thing is 9. That piece is 4, so that's got to be 9 minus 4. There's my 5. And if this is 5, this is 5. Okay? Then you just add up all the pieces and you get your perimeter. So that's 10 plus 10 plus 5 plus 5. 10, 20, 30 plus 8 is 38. And there's your perimeter. So it's a fun little puzzle piece once you remember that the tangent segments are congruent. Here, you wouldn't use the property of tangent segments being congruent. You would use the property of the tangent segment being perpendicular to the radius. You would say, ooh, I have a right triangle. And then they could ask you all kinds of questions like, if this is 3 and this is 4, how do you find AO? We'll call it X. Do you remember? Go back through your notes, your videos, your mind, and you think about two sides of a right triangle. How do you find the third side? A squared plus B squared equals C squared. Plug them in. 3 squared plus 4 squared equals what? Eventually you'll get to X equals 5. So work that out. Hopefully you'll get that answer. All right. Here, same thing. Here's my tangent segment. Perpendicular means I made a right triangle. Let's say they put a theta here. And they said solve for theta if AB is 7 and CB is also 7. Could you do it? Sure. You got opposite, you got adjacent, so you're going to use tan theta equals 7 over 7. You press your inverse button, find theta. You use tan inverse, and you'll get theta equals 45 degrees. All right? So this is our review. If you don't know what I just did here, please, please, please find my video on SOHCAHTOA. If you don't know what I did here, please, please, please find my video on Pythagorean Theorem. All right, so this is Intro to Trigonometry, and this is Pythagorean Theorem. All right, thanks for watching. See ya.